Hello everyone. Now we are going to discuss about the configuration, which is an important chapter in optical isomers. So before going to discuss about this various types of configuration, we have to know what is configuration. So the arrangement of atoms that characterize a particular stereoisomer is called as configuration. So normally to the carbon atom various atoms will be attached. So this arrangement will characterize a particular stereoisomer. Then it is called as configuration. Normally there are two types of configuration. One is a relative configuration and another one is absolute configuration. So let us see what is this relative configuration. So in this relative configuration, the enantiomer is related to standard glyceraldehyde. So we are relating the enantiomer with the standard glyceraldehyde. From that one we will determine the configuration. If the configuration related to L-glyceraldehyde, then that enantiomer is belong to L series. In case that configuration is related to D-glyceraldehyde, that is the enantiomer that is related to the D-glyceraldehyde, then it belongs to D series. Just we are relating the enantiomer with the standard glyceraldehyde. From that we can determine the relative configuration. So what type of configuration? Such thing is known as relative configuration. Then the next one is absolute configuration. So before going to this absolute configuration, we have to know what are the limitations of this relative configuration. Normally we are treating the compound with we are taking the compound and we are relating with the standard glyceraldehyde. If the compound is having more than one asymmetric carbon atom, then we cannot, or more than two, like that if it is going, then we cannot predict this relative configuration. So this is the main limitation of this relative configuration. In order to overcome this limitation, another one method, that is absolute configuration, has been suggested. So to overcome the limitation of this relative configuration, CAN, Ingold and Prelog, the scientists, they have suggested R and S system of configuration. That one is known as absolute configuration. So to assign the configuration, we have to follow certain steps. So what are the steps we have to follow? First thing, we have to keep the compound or atom which is having the least atomic number should be kept away from us. Okay. The next we have to go for the atom which is having the highest atomic number. Then the next higher atomic number followed by high atomic number. So your visual side is in such a way that it has to go like this. The atom which is having the least atomic number should be kept away from us. Okay. So first you have to see the atom which is having the highest atomic number. This is followed by the higher atomic number, then high atomic number. So in this one, the highest atomic number, the atom which is having the highest atomic number will get the first preference, and it is followed by the next atomic number, followed by the next high atomic number. Here we have taken the bromochloroiodomethane. Okay, so the example will be bromochloroiodomethane. Here among these compounds, the hydrogen is kept away from our eyesight. Iodine, that is having the highest atomic number. So your eyesight should go like this: iodine followed by bromine, then chlorine. Okay. Similarly, it is a reverse type. Here iodine is present in the right hand side. Iodine, bromine, and chlorine. So if your visualization, you just check here. Here we are going iodine, bromine, chlorine. So if your visualization is going from left to right hand side, so that is the clockwise direction. Here we will find that one. See, iodine, bromine, chlorine. So from left to right, if your visualization is going like this, then it is called as R configuration. See, if your visualization is going from right to left. Here also iodine, bromine, chlorine, but it is in the opposite direction, that is anti-clockwise direction. Then it is known as S configuration. This is about the absolute configuration. For assigning this one, we have to follow a set of rules called sequence rule. Okay, we will go through some few points about this sequence rule. If the atoms are isotopes, see here we are considering the atomic number. So in isotopes, the atomic numbers will be same. Then we have to go for the mass number. So if the result is not obtained by the rule number 1, the first number, then we have to go for the next atom will be considered. So normally first atom we will take. If both the atoms are same, then we have to go for the next atom. Here is the example: carboxylic acid COOH will get the preference over the CHO aldehyde group. Then double or triple bonds are present. What will we do? Then the compound, then it will be duplicated or triplicated, and that is more necessary for longer chain to get the priority. And if two chiral centers are present, then it will be denoted by the numbers. So how many atoms are present? That will be denoted by the number. So this is the sequence rule in order to assign the absolute configuration. I hope that you could understand what is configuration, what are the types of configuration. Thank you all. Thank you.